All right, so I guess the last two sessions of today, I hope that you are not too tired. So this will not be a fully technical presentation. I hope it will be like fun for you. Yeah, so today we will look from the attacker's perspective. So now we're a small group here. So I want you all to look from the hacker's perspective. So you're all black hat hackers now in this room. So we will try to make malware smarter. And hopefully we will start a new cyber pandemic from here in Lausanne. So first of all, little information about myself. My name is John. I'm the co-founder of ProDeft, which stands for Proactive Defense Against Future Threats. It's a fancy name. So what we do is we try to prevent breaches before they happen. So there is like a common perspective. You say like black hat hackers are always one step ahead of the white hat hackers. So, well, this is true, more or less, because they have access to a lot of data, where the white hat hackers still considering these like GDPR issues and everything. So they have the all data available. They don't have any legal concerns or whatever. So our full focus on to detect the new technologies of these bad guys, what they are using, to be one step ahead of these guys all the time. And we monitor the sophisticated APT groups, try to understand their next targets or what technologies they use. So this is highly relevant with our presentation today. So I have more than 20 years of experience in various fields. I published academical papers and journals related with malware, privacy, covered channels, secure computation, and some other things. I got awards from different organizations. One is from the US Department of Defense, from a cybercrime challenge. Over 1,200 teams from 52 countries. I became the grand champion. I got another one from JCI, and the last one is last year I was elected as one of the digital shapers of Switzerland. So you can find the rest on my LinkedIn if you're interested to learn more. So in order to understand how we apply a little bit of machine learning and make malware smarter, we need to understand what happened before us. Of course, we are not the first one who will try this kind of making malware smarter. So this is a historical example from 80s. Actually, it's like it's a game. So it's played by some people are just like nodding know this game. So it's played by two players. So does any one of you know the name of this game? Yeah, exactly. So the only person in the room. Yeah, it's played by two players. It's from 1984. So the idea is you write your program and the opponent writes their own program. So you have like this memory space. So it's a turn-based game. So like each instruction is played one by one. So what is the goal? So this, what you see here, is the whole memory. So when you input your code, this is a simulation environment, and you click play, and your code lands on any region of the memory, so you don't know where you land. So it's written in a primitive assembly language called red code. It looks like this jump or move instructions. So what your aim is to kill your opponent's program and to dominate the memory. So it's basically the first kind of example of computer war. So how you kill it? So you basically write a data section on top of the instructions of your opponent's code. So people try to define different strategies to win at this game. So it became quite popular, and then it's just like, you know, it died. So we have like PlayStation 5 now. We don't need these games. So it's inspired by Creeper. It's the first worm in history. It's written at 1971. And a lot of different worms, or they are calling it warriors, are developed over the years. So there are like 3 dominant strategies, like rock, paper, scissors. But it's more complex than that, of course. So this is how it looks like when you click run. So basically, both codes kind of like try to kill each other. So those 2 gentlemen, John Perry and Ryan Coleman, I guess around like 80s again, they wrote 2 academical papers how to integrate learning into these warriors. So I found this as like the first example of using some kind of learning in a computer worm. So John Perry got successful because he attended one competition. So there are like really national competitions of this game. So he got the 3rd place by using his smart warrior. Of course, in order to understand first like how we can use the AI, we should also see like how other technologies misused over time. So this is a graphic. It's a bit dangerous to put these kind of statistical thing, the APFL. This is a subjective kind of thing. So it's based on our perceptions. So don't judge me, okay? So there are like 4 major technological advancements that we think that the malware kind of obtained some kind of functionality. So they became better. So there are like groundbreaking events happening those years on the y-axis, and the x-axis is the impact of the malware. So connectivity and hardware power is trivial. It's not exciting as the cryptography and the AI. So as you all know, like in 2008, the first Android devices are appearing on the market, so it increased the mobile era, the connectivity, and the malware started spreading to more devices. There's the adaptation of the first World Wide Web around 90s. So basically, most of the things are trivial here, and we have like the quantum computing upcoming. We just like approximately it will just like increase the impact of the malwares exponentially. About like the cryptography, as we mentioned earlier, like those 2 technologies we say are misused heavily over time. The first ransomware in history was around like 1991. And now today we are like seeing ransomware cases all the time. You know, like whenever you search for any kind of cyber threat, there are like different ransomware APT groups appearing up on the web. So what happened over the years? First, the hackers, they tried to use cryptography, but the difficulty was they did not know much about cryptography. So the first ransomware, they used like symmetric encryption. So they put the key inside the executable, they infected a lot of machines, and then they demanded ransom. And then the antivirus companies, they started writing, you know, decryptors. So they thought like, okay, there's something wrong with it. We are not like making money. So let's use something else. So they searched and they adapted like a symmetric encryption, like RSA keys, and they started like encrypting with a public key, which can also be like, which can only be decrypted with a private key. So they start like generating some money. And like the recent years, we saw like a lot of adaptation of cryptography in the recent cases, especially in the ransomware as a service business. And where like you have like a binary which works offline, so there's no connection between the victim and your server. So basically you kind of get the payments from Bitcoin or whatever, so everything is kind of like anonymous for a regular kind of investigator. And on top of that, now we have like double extortion schemes. So hackers said, okay, so we're encrypting like the victims, but some of them are not paying. Why? Because some of the people, they love to do like backups all the day, right? So one IT guy comes up and saves the day saying that like I have the backup, so we don't need to pay. So the hackers, they invented new things. So they said that, okay, instead of like encrypting the data, let's move the plain text data out of the system to the cloud somewhere, and then tell the victim, if you're not paying, I will not decrypt your files. And on top of that, I will release those files, you know, to the public. So that is the thing that they're doing now. So it's not for the future or anything. And we see like a lot of companies, even if they have the backup, just to save few files, they are paying like millions of dollars. So it's like a really profitable business. And these are kind of prediction for the AI, and I'll explain more in the future, in the next slides. But first, like, let's focus on cryptography and how it's misused over the time. This is useful because we need to understand it to have another perspective about the AI. So just bear with me for just one slide. I'll explain how cryptography is used over the years offensively. So this is a really famous book. Who are like interested about the malware scene. It's written by two gentlemen, like Adam Young and Moti Jung. I guess Moti Jung is still like he's a senior researcher at Google. So they first described cryptoviral extortion in 1996. So the idea was to extract data from the host machine and without revealing any information about what's being stolen. So I'll just like explain more in detail. So they published this book in 2004. This book contains really interesting, let's say, sections. David started reading it. I don't know why, but it's basically focusing on how like hackers can misuse all these like crypto domain. So there are like three main topics that they described, and the last two of those are really interesting. Computational secure information stealing. So when you write a malware and you spread it all over the world, and security researchers can identify it, and then they will just like write a report, and they will show like what you're trying to steal. So in this kind of book, they are using private information retrieval algorithms, so that like you send like an encrypted query to your malware, and the malware traverses through the data in your computer, so just like hypothetically, and it extracts something from your computer. So even if you have the full source code of the malware, and even if you can observe the whole network traffic, you cannot identify what's being stolen from you. There's also like a section about the kind of extortion tactics which we see today, but I'm not like referring to those. But if you're interested, you can find this book and read it. The crypto counters is another exciting thing. We used to see a lot of like time bombs in malware, which is like a certain date the malware triggers. So you set like, for example, the infection happens today, but the malicious functionality will get triggered at the end of the year. So you write it in your source code. So it's like a simple if-else kind of code chunk. You can do it. So when the researcher analyzes the malware, then they can understand that it will trigger at the end of the year. But if you use crypto counters, like it's basically using homomorphic encryptions and calculations based on top of that. So you have like a specific thing that can trigger the malware, and if you even have the full source code of the malware, you cannot understand when it will get executed. So it might be the end of this conference, or when the temperature drops below 0 or whatever. So So those are the main points, and it's kind of like explains us the hackers, they're kind of like adapting themselves whenever they see the chance. But it's not like as fast as you think, because now like you're wearing the hat of the black hats, you're making huge amount of money. So when do you kind of try to do new things? When somebody, you know, cuts your kind of earning, or something happens and they kind of block your spreading or attacks. So it's going fast, but it's coming at a certain point. So let's switch to the machine learning and AI. So in order to adapt this like learning or make our malware smarter, we need to make the comparison between the malware and a biological virus. So it's like a really simple comparison sheet. So we have the spreading in both malware and general biological viruses, right? Viruses spread all the time. So we have different viruses spreading almost like 1,000,000 times an hour. And the malware also spreads itself. Well, it started like as a primitive thing by just like copying itself, and it became a little bit more advanced by using polymorphic or metamorphic kind of spreading mechanisms. It started spreading with file sharing applications. Now we have like a QBot, which kind of obtains the whole email data set of the victim and then uses that data set to send out a new email campaign. It sent over maybe 200 million emails in the last year. So we have this like spreading mechanism in both kind of organisms, let's say. And we have the persistence. So the virus loves to stay at the host, right? So whenever you see like an antivirus, then you're dead. But they always try to kind of replicate and gain new functionality to stay at the host. For our like persistence model in the malware, you can consider it as like a rootkit, right? So you're at the brain kind of the computer. So you want to stay invisible to the antiviruses. And yeah, like evading antiviruses is another kind of problem that the malware authors try to struggle for many years. And in the recent years, they started using some kind of learning algorithms. So they try to tamper with the learning algorithms of the antiviruses or these kind of host protection software. So there are like 2 points that we need to discuss, the self-mutate and the survival part. And the question is like how viruses evolve. So they're not that smart to say that like, okay, we need to evolve right now. So they just like replicate themselves. And then the mutations happen, right? So a mutation can cause something in a good way or in a bad way. So when you mutate, you can gain a new functionality, like we're living at the 3rd or 4th phase of Corona right now. So we have the Omicron, so it's spreading faster, but it's less deadly. So you're just like spreading to more environments. So if the viruses are that smart, they will say, okay, now it's time to kill everyone, right? So they're just like, you know, trying to replicate and adapt their environment. So how we can create a similar thing for the malware so that it can replicate itself. We will make it more smarter, so it will not be like a virus. But first we need to simulate a mutation. So I wrote a thesis about the subject in 2011, like 11 years ago. It's called Increasing Chances of Survival for Malware Using Darwin's and Richard Dawkins' Theory. So the idea is, again, like implementing certain functionalities from the nature to the malware so that it can adapt its environment and survive the worst conditions, let's say. So what is the condition of dying for us? So for a virus, it's easy to explain. So again, there's like a antivirus within the body, an anti-cell, so it just like kills you. So in our case, it's almost the same, right? When we infect a PC and there's like an antivirus which detects us, or if we crash for some specific reason, then we are dead. So we want to prevent this. And in this comparison chart, the structure is almost like the same. So we have the lines of code, and the viruses, they're like lines of RNA, DNA, whatever. So the mutations are basically the changing of these codes. And the malware is like a sequence of codes. So if you think about like the instruction level, I think it will be a little bit technical to explain that from the coding perspective. But you can think of the program as like ones and zeros. If you switch one to 0, probably your computer will crash, right? So the software will crash, not the computer itself. But actually, it might also change the behavior. So for example, some of you guys are here from the APFL. For example, the assembly instruction for jump equal 7-4 in hex. And if you just like switch one bit, it's 7-5, jump not equal. So it's just like changing in direction. So gaining a new functionality, but it will probably crash. That's what I'm saying. So I'll not explain this in the really low level. So I'll just like take you to a one level up. So let's get a new function, like an API call from a benign program and add it to ourselves. So we are at the host computer and you see some like Internet Explorer is running and you just like take an API and add it to yourself. What happens? So you will probably crash, right, again, because you're not expecting that API to be called or the return parameters are wrong. Something is wrong there. But if you define a fitness function, so what is my fitness function here? We mentioned that the condition of dying is the detection by the antiviruses. So my fitness function here is the detection rate. So if I'm not detected, I'm better. So if I get a new functionality somehow, and if I survive, if I'll not crash, that means that the less detection, and maybe I'll gain some new capability. If we iterate this, like the viruses replicate, I don't know, like 1,000,000 times an hour, but we can replicate this like 1,000,000,000 times an hour. So we will eventually create something which will contain the malicious code in itself, but also gain new functionality from its environment. So now my colleague Emre will explain other functionalities that we can add to our new malware. I hope you kind of like get the basics of what we're trying to do. So thank you.
Hello everyone, I'm Emre. I'm here to actually extend the ideas that actually John has given us. To talk about myself, I am Emre, as I said. I am actually working as a security researcher on Product as the same company. And my background is mostly based on the computer science and the mathematics, and I'm mostly interested in the theoretical computer science areas and the AI capabilities of malicious software. So, as John has given us the black hats, we actually create a malware to create a cyber pandemic. So I will actually extend our ideas to create some modern malwares and increase our chances to actually stay on the host and increase our impact. So what I mean by impact and the survivability is depending on the subject and our malware. So first thing we gonna be talking about is the detection, the environment detection, and most of the time the environment detection softwares and the monitors, the hardened environments are very publicly available, and most of the time these frameworks are using machine learning softwares, machine learning techniques in order to create a hard time for the malwares. But as each hardware and each operating system has unique identifiers, each host machine has unique identifiers. We can maybe call some as I said, hardware parameters, maybe some software parameters, maybe some, good programs running on it. It is not a new problem for the malicious software developers to actually get rid of. At least for the last 20 years, it is very well-known thing that reverse engineers and malicious software analyzers using virtual machines. So this is a very big, cat and mice game. So we can actually use some very unique stuff to actually bypass. So if we are writing a malware, well, there are some things that actually you can't actually simulate on a virtual environment. What we can call for some extent to these examples, maybe user interaction and some hardware, response times, etc. And these are very, hard to replace because as the, other talks have talked about it, it needs very much of real human data. And one can actually argue that how can a malicious software can, detect these, even if the security and the data scientists can't actually get this data and cannot find this data. It has very long time of, time spent to get this kind of data. But it is very easy actually for a malicious, software, since as the John told, these guys has most of the data, and these data is very, dream data that actually can be for a, data scientist. Since there is no legal team or something like that for a malicious team, they can, if they can actually release a, ransomware on an organization, they can actually get your photographs, their emails, their text, and this data is fully, real data, and they can actually use this data in order to get to understand if the environment that they are actually executing on is real or not, is hardened or not. And this is actually very useful if you are trying to hide yourself. And the next step is to actually increase your survivability on the system. So you can actually think about a malware. The malware that we are actually talking about here, most of the time using 0 days, not even the 1 days, that is actually can be detected easily. So if we are talking about this sophisticated targeting, then we need to actually use our chances very well. So actually the life cycle, the life time of a malicious software is very crucial, that you can actually use, as the John talked about. You can use some time bombs in order to execute the right time, but this time stuff is very sensitive. If you can understand when to run, then you can actually get the most of the data. And the targeting audience is very important to actually use for a malware to understand when to run. And this may be a destructive operation, maybe some data extraction, or maybe none of them, just to stay there for a long time and just wait for a command. And this is very noisy thing to actually consider, since the running at the right time brings the strategic capability. So you can actually access more data when you just find the right time, and you can actually create some less noise to decrease your chances to be detected. And the unpredictability is always puts you one step ahead when you just compare to the defensive side. So at the end of the day, we should be saying that if we are writing a malware as a black hat, our malware should be smart enough to understand the environment. And if it is using actually some technique that needs to be selective, then it should do it in a selective way, in a smart way, we can just call it. So as these guys have so many data about the processes and the real ransom data that actually are running on the organizations, they can actually select their injection target by just using this data. And this injection targeting is also very differentiate between the host application actually you are injecting. So as some of the malwares on the publicly available reports, they are using the same techniques over and over again. But if you are using another host to inject, And to adapt yourself, you need to actually use your memory according to that. If you are on a very actively memory using application, then you should be using more memory. And if you are using less memory on a less memory, using host, then it won't be that much, suspicious. And for my time is coming to end, I will just be talking about using this smart usage, these weapons, the cyber weapons we can actually talk about, is the malwares often have the spreading capability, and the spreading using by, network and maybe other mediums are very hard and noisy. And in order to decrease these attempts, you actually use some machine learning aspects, including some random forest maybe, or just detection, bypassing algorithms. And when I talk about the less attempts to, spread, I'm meaning the less is more, philosophy here, to use less, instruction, less methodologies to get more impact. So as the detection systems are evolving constantly, as the other talks have tried to describe, the detection data is very important for the malicious, developers to actually adapt themselves to these kind of detection mechanisms. So at the, for the last, there is a, research going on for this, idea, and it is actually very two-sided thing. Well, today is the most popular, malwares are the ransomwares. However, when you just think about it for a, malware developer, a ransomware developer, it is not profitable if you, running on a host that is actually already ransomed, right? If another ransomware actually, by chance, has been there before you, and all the files are encrypted, then you can't actually encrypt anything to get profit. So at the end of the day, if a malware, a ransomware, can detect if another malware is there also, and if they can actually work together in order to increase their chances to get profit from the user, it would be the best case for these malwares. And in order to actually increase this chance, they are actually playing a game of mice and cat. But if they work together against the system, then they can increase their profits by a big amount of time. And consider having different malware variants for the same host is not as popular as today's techniques that is used, but it is very easy to see in the very short term future. So we can actually say this at the end of the day. We try to create a cyber pandemic, and if we are using the AI capabilities of defensive side, offensive side on a malware, actually at the end of the day, I am asking you that if we are ready for a cyber pandemic. So I think my time is over, so thank you for listening. I'm sorry, by the way, if my voice is doing So that's all. Thank you.
Hi, maybe Chan, you can also come up. So we have a couple of minutes for a few questions. If anybody wants to jump in, the gentleman here.
I'm wondering, who are your customers?
So yeah, like this presentation was not about the company itself. It's just like giving you some kind of perspective. So
Okay.
we work with the financial industry mostly. Like 95% of our customers are from financial industries, mostly retail banks. But we also work with different sectors as well, like aviation, insurance, e-commerce, healthcare. So we like working with 9 different verticals. We have over 150 clients using a cyber threat intelligence platform on a daily basis. They are receiving the threats that might affect themselves or their employees or their customers. So you can check online that like all of the APT groups that you hear about on the news on our website, or like if they're made public, you can see all the internal details about how these hacker groups operate. So if you understand more about these kind of things, then you can defend in a better way. So that is the idea. Thank you for your question.
I have a question. So you talked about having this malware that would be able to evolve. Have you tried? Have you built anything that evolves?
Like it's like an exemplary case in my thesis, like 11 years ago. I did some kind of like a prototype and wrote like a fitness function, and then used the genetic algorithm to kind of adapt itself. But it was just for the thesis. So.
But are there, so genetic algorithm exist? I mean, there are some people playing with them.
Yeah, like it's now accessible for everyone, right?
Have you seen any genetic algorithm being used as well?
Currently, no, we don't see much of AI usage in malware. Like there are like simple tryouts, but there are a lot of different AI problems that the attacker side kind of needs to get their hands on. One of the biggest one is the victim attribution. So like the general setting, like the attacker attribution or like criminal attribution is the thing that we focus on. So we do a research about author profiling and everything. So what the hacker thinks is when they kind of spread to a computer, they see a lot of IP addresses are connecting. So they need to kind of understand who are the victims. So maybe from your side, it's kind of like, it doesn't make any sense, right? It's just like attacking to somewhere. So why he needs to understand who is the victim? Because like they're spreading to thousands of places, and they need to select the most profitable ones to make a ransom demand. So it's like attribution for the victim. That's a problem for our side as well, because we monitor a lot of IP address being attacked. So we want to prioritize like how we can inform them. So which is the most important one. So there are like really tiny points which can be easily solved with the recent technologies. Maybe if we like put more effort. But if we just like look at from the malware perspective, we didn't see any kind of malware which can kind of use these techniques. So sorry for the long answer.
Okay, maybe a last question. Martin?
And with your cyber threat intelligence platform, are you using also some sort of machine learning techniques for defense? I mean, you're seeing a lot of malware samples, right? So are you actually employing something that's not just, I don't know, rule-based or?
So the platform is like a really complex thing with 16 different modules. For each module, there are some parts that we use ML techniques. For example, like phishing detection is really, focusing on that problem. So you have like keyword-based detections, also like image-based detections, and the format of the page and everything. So you kind of have like an algorithm which can take one piece from each and then create like a function to detect better, to serve your customers better. About the detection from like the forums or the exchange methods of the hackers, ML is not heavily used. And also on top of that, we use a lot of like human and SIGINT resources to verify the threats. So still we're not at that point. So we cannot use common algorithms to aid that kind of module. But as I mentioned, we're like now doing research on author profiling. So we're trying to understand the origin of the hackers from their writings, like their chats and texts with the victims. So it's like a three-pillar research. It starts with the textual data, and then there's another research going to analyze the resource of the attackers. So when there is like an attack, so you know like how much they pay for each kind of service, you try to approximate. So if they use like exploit or something, then it automatically says that, okay, so this requires some budget, so it's not something for the script kiddies to execute. And the third pillar is to monitoring the social events happening, like conflicts or everything, to like sum up everything to create a better attribution. So we make use of like ML in different perspectives, but we are not like focusing that technology on core. Yeah.